So we know what is lean system, the principles, and some kind of a structure that how it can be explained, a Toyota house, or with the five principles. Let's deep dive into some tools that are important, right? As you guys can see, I'm back in the sunroom. My wife is working in the office, and then she said I make too much noise, so uh, let's get it going. It was a beautiful day, as you can see. Let's get into continuous flow. So what is the objective of continuous flow, right? So I want to eliminate all the waste, right? Putting the steps together, eliminate all the waste between the steps. So I will have less labor needed, less operators needed, less space needed in a compact layout, less inventory needed, and the lead time, right? The time for me to react to changes will be very low as well. And also, I want to align my production process to the pace of the demand. So we talk about that in pull settings, right? So continuous flow make it easier to implement a pull system. We're going to talk more about that, which means producing in the same pace of the customer. The pace of the customer is also known as tech time. So we're going to learn about this as well. So by implementing continuous flow, and I did it many times in consulting for different types of companies, when you do that, you gain space, you reduce inventory, you find out problems that you didn't know that were there, and you have the time to fix them, transportation and all kind of benefits for that. So the continuous flow, the way to use that is to use cellular manufacturing called U-shaped cells. And we're going to see why and some important things in implementing cells. So first thing to understand about continuous flow, right? So let's take a look at the impact of continuous flow into lead time. So imagine that I have these three different processes, A, B, and C. Oh, it's supposed to be A, the first one, okay? So it's like a saw and a drilling and a welding there. Let's say that I have 1 minute for each one of those, but they're separate and they have a transportation batch of 60 parts. Let's say that, we put in the pallet, you move with the forklift to the next process. Very common to happen out there. So how long it will take for one part to go through all the steps until the end? Remember, our batch is 60 parts. So we have 60 in the beginning, right? And then how long does it take? Calculate that. So the first batch takes 60 minutes, right? Because you take the first part, you do it, it's ready, but you have to wait for the other 59 parts, right? That will go, and then I have 60. So now I transfer to the next one, and then I take one at a time again, 60 more minutes. Then you have the batch of 60, and then you take one at a time again, and 60 more minutes there. So at least 180 minutes. And that happened because of transportation batches. That happened because those steps are far away from each other. What happens if we implement continuous flow? If we make these process, so don't change the process, don't change technology, just arrange them in a way that are one on side of the other. So you make one, you pass one. So that's called a continuous flow or one piece flow. So when you do that, what is the lead time? Imagine that I have the same 60 parts, okay? But now I'm giving directly to the next step and to the next step until the end, right? So it takes 1, 2, 3 minutes because it's 1 minute A, 1 minute B, and 1 minute C. So 3 minutes, the first one gets out. And then every minute I'll have a part that will get out, right? Because everybody's producing one every minute. So after 62 minutes, I have the same batch going through all those three steps. And that's the power of continuous flow. You can reduce drastically your lead time by putting the process together. Again, no big investment, no big changes of process, just organizing the process, the method. And that is all what lean is all about, how to organize in a very efficient way. So I reduce my lead time, I increase productivity and all the other good, reduce inventory, on-time delivery increase, and all that good stuff, okay? So the U-shaped cells are usually the one that we use to implement continuous flow. And you can see a U-shaped cell here. So it's U, That's why it's a name. And you can have people in the middle, in both sides, right? And they work in different steps of the process. That is good because it reduces walking time. It allows materials to be put in from outside, so don't interfere with the workers' time. It takes a lot less space. Sorry. It allows different product flow and different volumes. So different product mix and different volumes, which is very important. What are the alternatives for that? So alternative for that will be using this kind of layout. This kind of layout, it's called, do you guys remember from core operations management course? Do you? So here I'm organizing by processes, right? So it's a process layout, right? No, don't ring a bell. So let's take a look at here. You have the lathe department, all the equipment in one place. Drilling department, all the milling, equipment in one place here. All the drilling in another place, all the grinding in another place, all the final inspection in another place, right? And then the products have to go through those steps until it gets to the end of the process. Okay, so in this case, I organize things by process, and the product can go. The product can go anywhere, right? So it's a very high flexibility, but I lose a lot when I move things from one place to another. So you gain flexibility, but you lose volume, right? So remember that job shop process. Yay! Hope you guys did remember that. And then here you have a line flow, right? And the line flow was that, you get a lot of volume, but you lose a lot of flexibility because you have just one flow. You cannot vary the volume too much. If you plan a line for, let's say, 400 people or 200 people, you don't have much variation that you can go on because it will be too far away from each other. So we do 1, 2, 3 steps, and then you have to go back to the first step. So it's great for volume. It's very bad for flexibility. The U-shape combines those two things. It's good for flexibility and it's good for volume. That's why that's the preferred layout. And also it reduces a lot of waste, especially on transportation and motion, right? Because the workers can be in one side of the cell, but also you can balance the work the other side of the cell, right? So let's say this guy can go here and here. This can go here. You have the side there, which also take a very little space. And you can have products that can go in different flows. You can jump from one side to the other, so they don't have to go in the same steps. Like an assembly line, like automakers, right? Car manufacturers, the car goes through all the steps. Every car, every model have to go to all the steps, right? So in a U-shaped line, that is not the case. And some big companies, like big products, implemented that. So I worked with Embraer, which was actually acquired by Boeing 1 year ago, 1.5 years ago. It's a Brazilian airplane manufacturer, and they design a airplane line that is a U-shape. Of course, like a huge U-shape, because actually the airplane is going and doing the U, but still a U-shape, and you have a lot of advantages of being that compact layout system.